Welcome to EMEE6002 Sustainability and Climate Change. This topic is about solar energy system. The sun is one of the major energy sources for the Earth. There are three major solar radiation components, including the direct beam, which is the light of sight direct beam from the sun to you. Another beam is called the diffused beam, which is the reflected ray from the sun through the atmosphere on the Earth. Another is the extraterrestrial beam, which is another reflected beam from the outer atmosphere on the Earth. This is the power spectrum of the sunlight. The x-axis is the wavelength and the y-axis is the power. The direct beam contributes the highest power, while the global beam and the diffused beam contribute less. And there's a factor called the air mass. When the air mass increase, the power contributions by those beams will decrease. So the influence of the Earth atmosphere will also depends on the length that pass from the sun to the Earth through the atmosphere. For example, the direct beam will experience a shorter atmosphere length, while the diffused beam will experience a longer one. And for example, those areas along the equator area will experience a shorter path in the atmosphere compared with the area, for example, in the North Pole will experience a longer path. The air mass is a ratio of the actual passage passed through the atmosphere and also related to the thickness of the atmosphere. It is given by these equations. Air mass is equals to 1 over cosine 90 degree minus beta, where beta is the angle of elevations. In Singapore, in the equator regions, beta is 90 degrees when the sun is directly above us. Okay, you need to look up 90 degrees to the sky to see the sun. Okay, so this angle beta is 90. While in the North Pole, the sun is almost horizontal, so beta is 0. Okay, you can simply see the sun in the horizon. So in Hong Kong, the altitude is about 23.5 degrees. So the angle of elevation is 90 minus by the altitude of Hong Kong. Okay, it's about 60 something. So the angle of elevations in the summer is about 60 something degrees. In other words, the higher the altitude, when we get closer to the North Pole, so the beta angle will be lower. In other words, the sun will be lower and the path passing through the atmosphere will be longer, and therefore the attenuations will be higher. So we can first calculate the air mass according to these equations. So this number 90 minus beta is in fact the value of the altitude, which is 28.7. So we cosine 28.7 and divide it by 1, and we can get this number. Air mass is equals to 1.14. And then once we get the air mass number, we put the air mass number here, exponentials to the power minus air mass divided by 3.826, and then 100% multiplied by 1 minus this number will be the attenuation number. So in this case, the attenuation is 23%. So we can make use of these equations to find out the attenuations contributed by the atmosphere. When the sunlight experiences more atmosphere, then the attenuations by the air will be higher. So that's the reason also why the solar power in the equator region is much stronger than those in the regions close to the North and South Pole. This is the solar power intensity diagram showing the level of solar power when the sun rises in the morning and then sunset in the evening. So when the sun is up in the sky at 12 p.m., the light intensity is the highest. This is the contributions by the direct sunbeam. And then throughout the whole day, the diffused beam, where you cannot see the sun directly, but you can still see that the sky is bright because of the diffused beam. So even though the sun is in the west during the evening sunset period, when you look to the sky in the east, the sky is still blue and bright. This is because of the diffused sunbeam. So what is the best angle for the installations of the solar panel? If you want to install the solar panel in Hong Kong, or install in Beijing, London, or in Singapore, what should be this angle? Let us first of all understand how the Earth moves around the Sun. During the summertime, because of the inclinations of the Earth, the northern hemisphere is directly facing the Sun. Compared with the southern hemisphere, the distance between the southern hemisphere is much longer. Therefore, summer in the northern hemisphere, like in Hong Kong, means the winter in the southern hemisphere, like in Australia. After summer will be autumn. After autumn will be winter. And in this case, the southern hemisphere will face to the sun more directly compared with the northern hemisphere. So the situation reverse. Hong Kong, China, or North America are now in winter time, and those cities and countries like in Australia will face to the sun more directly, and this is the reason why we have summer. I believe that you should have learned this in your primary school, right? So we all know that the Earth moves around the sun, but because of the self-rotations on the Earth, so any point on the Earth will see the sun. Looks like that the suns move around us, because when the Earth start facing the sun rises in the east, and then when it moves to another side, then the suns will behind us, and then sunset in the west. So we can draw this diagram, what we call the celestial equator. Celestial means the sun. This is the path of the suns that looks like move around the Earth. This is the path of the suns that looks like how it's move around the Earth relative to stationary positions on the Earth. Of course, it's not because of the suns moving around the Earth. It's because of the self-rotations of the Earth. So it seems that a fixed point far away from the Earth, the sun, looks like it's moved around us. So the purpose of this diagram is to show how the path of the suns will move from the east to the west in a day. This is important because we need to find out the path of the sun on different seasons. In the summertime, in the spring, or in the winter time, the path of the suns are different, and therefore in theory, the elevation angle of the solar panel should also change in different seasons. The best scenario is that the surface of the solar panel should be directly facing to the sun in a perpendicular angle. So if we can measure the angle between the suns and the elevations, then we can find out what should be the best angle for the insertions of the solar panel. Now, take the case in Hong Kong. The position of Hong Kong is about 23 degrees. This angle is 23 degrees. So, in order to make our panel directly facing to the sun, the angle of elevations of the panel should also be 23 degrees, which should be the same as the altitude of that locations. And these angles may vary a little bit during different seasons. In summertime, the sun will be higher in the sky compared with in the winter time, where the sun will be lower. The angle of elevation is lower. So in the summertime, when the sun is the highest above us, the angle of elevation, which is the altitude of Hong Kong, should be about 22.3. And this diagram shows the solar intensity across different hours in the day and across different months in the year. Let's start in the morning at about 6 or 9 a.m. where the sun rises and then the sun intensity getting higher and higher. And it's the highest at noon, and then afterwards it dies down after sunset. And in the northern hemisphere, the sun intensity is the highest during the summer season in June and July. So you can see the sun intensity is highest during these 2 or 3 months. And then in the winter time, the intensity is lower, even though it's at the noon time.